So in addition to the Pythagorean theorem, when we were working with right triangles, we also have our primary trigonometric ratios. And these are sine, cosine, and tangent. So in order to use these, you need to remember how to label a triangle with reference to an angle. So we've already been talking about the longest side being the hypotenuse. And this is true no matter which angle we're talking about, the longest side is always going to be the hypotenuse. But we also have the opposite side and the adjacent side, which depend on which angle that we're talking about. So opposite, I always think of opposite as straight out away from our angle. In this case, we're talking about angle theta. This is going to be the opposite side of my triangle. And the adjacent side is part of angle theta. So angle theta is here with this hypotenuse as being part of it, and this short side is being part of it. And the adjacent side is the other, we call it the other side of the angle adjacent. That is not the hypotenuse. So opposite side straight out, adjacent side part of the angle right next to it. That's what it means when we say adjacent to, is right next to the angle that we're talking about. So our primary trig ratios are based on this diagram of a triangle. And again, if I was going to label then, let's call this, we can call it angle, this is angle phi. The opposite side from angle phi would be over here. And the adjacent side of angle phi would be over here. So again, opposite and adjacent depend very much on which angle that we're talking about. And so from those, we have our primary trig ratios, which are SO, CA, TOA. Maybe somebody's taught you SOHCAHTOA as a way to remember sine, cosine, tangent, which are the ratios. So SO stands for, S stands for sine. So sine of theta, sine of angle theta. O stands for opposite. So it's the opposite side divided by H stands for hypotenuse, the hypotenuse. That would be my trig ratio when I'm trying to write it in terms of a triangle. C stands for cosine, so cos of an angle is equal to A stands for adjacent, divided by H stands for hypotenuse. And TOA stands for tangent of my angle theta, opposite O, and adjacent A. So if I have, here's a random triangle, has to be a right triangle. Let's say this is angle theta, and I'm looking at 3, 4, and 5 as my sides. So for this triangle then, sine of theta, again, sine is opposite of our hypotenuse, so opposite is 3, hypotenuse is 5. Cosine of theta is adjacent, well, the adjacent side is 4, hypotenuse is 5. And the tangent of theta is the opposite side, 3, over adjacent side, 4. So we can write these trigonometric ratios as fractions. We can also write them as decimals. So like this would be 3 over 5 if you did the division, 0.6. This is equal to 0.8. This is equal to 0.75. In this case, they all happen to be terminating decimals. They aren't always. In fact, most of the time, they are irrational numbers that have no pattern and no end, but they can be. So in this particular triangle, these would be my trigonometric ratios. Now, this is knowing the sides of the triangle and not having a clue what the angle is. If you do know what the angle is, your calculator can actually tell you what the trigonometric ratio is. So in this case, if I pull up my calculator, it's telling me for a triangle with an angle of 42 degrees, what would be the ratio of the sides. So I'm not going to actually use this yet. I'm going to use this later on. I'm just going to practice typing these into my calculator. One kind of important step is you need to make sure that your calculator is in degree mode. So if you don't know, you might have to check the setup or the settings on your calculator. On my calculator, I go Shift, up here says setup, and then go down to where it says angle, and I want it deg for degrees. I'm going to change that to be deg for degrees, and then that will get me the correct ratios because I'm dealing with all my angles in degrees. When you get to grade 11, we will also talk about another way of measuring angles called radians. So that's why you need to know how to swap your calculator back and forth. But for this class, we're just going to be working in degrees the whole time. So hit enter. And then it's just basically a matter of typing these in. So find the sine button on your calculator. Sine of 42 means what would be the ratio of the sides in a triangle with an angle of 42 degrees. And it's telling me 0.6691. It says to, in this case, do 4 decimal places. So 0.6691. Okay, so if you're not getting this number when you type that in, double check that you're in the right mode. That's going to be kind of important. You might need to check your mode settings. Okay, next one, cosine 76. So again, take the time to actually do this yourself on your calculator. Type in cos 76, and it tells me the answer is 0.2419. So it's saying, in other words, if I had a triangle with an angle of 76 degrees, pretty steep angle, 76 degrees, what would be the ratio between the adjacent side, that would be here, and the hypotenuse? So it's not surprising, it's like 0.25. Tangent 45, so pull out tan 45. Oh, 1, exactly 1. It's the only time you're going to get that. Tangent 45 is 1, no decimals, just 1. And tangent 90, last one. Oh, tells me it's an error. In other words, I can't actually take the tangent of the 90-degree angle. I can only take the tangent of the acute angles. So no answer to this one. It's an error, because if this angle was 90 degrees and I have to have another 90-degree angle in my triangle, then I don't have a triangle. Okie dokie. We can also use our calculators to quote-unquote go backwards. In other words, if we know what the ratio of the sides is, your calculator can tell you what the angle in the triangle is. So, for example, if I know that the tangent of my angle is 3.72732, then I can figure out what angle produced this ratio of sides. So on my calculator, I'm going to clear out that. In order to actually do that, tell it to go backwards, I'm going to take the inverse tangent of my decimal. So on my calculator, that's a little tan -1, little tan inverse of this 3.732. In other words, this is saying go backwards. I know what the ratio of the sides is, and I want to know what the angle is. So inverse tangent of 3.732, and it tells me, oh, the angle that gave me that, if I was going to round this to 2 or 3 sig figs, would be 75 degrees. 70, oops, I'm going to put my calculator away for a second. 75 degrees. In other words, if I have a triangle with an angle of 75 degrees here, the ratio of the, again, tangent opposite side to the adjacent side would be 3.732. That's what all this is telling me. Okay, so example number 5, we want to solve the following again to the nearest degree. So sine of an angle, some angle is 0.5, it's a half. And I want to know what that angle was that produced a sine of 0.5. So in this case, I'm going to use inverse sine of 0.5, saying go backwards, take the inverse sine, so shift inverse sine, 0.5, and that tells me, oh, my angle A is 30 degrees. Letter B says, now I have a cosine, I have the ratio of the adjacent side to the hypotenuse of 0.5, what angle would produce that for me? So in this case, then I'm going to go shift cosine, 0.5, and it tells me that was actually, so this is inverse cos, 0.5, and this is theta equals 60 degrees. So a triangle with an angle of 60 degrees will produce a cosine ratio of 0.5. And the last one, tangent is 0.48 So x is going to be inverse tangent of 0.4877. Type that into my calculator. And that tells me x is 25 point, well, it says 998. So if I round that actually to 2 sig figs or 3 sig figs, that would be 26.0 or just 26 degrees. Okie dokie. Guess I got a little ahead of myself. Here it's got SOHCAHTOA. So again, sine S opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. And you're going to use that SOHCAHTOA quite a lot, so keep that in mind. We can use SOHCAHTOA or the trigonometric ratios not only to find an angle, but also to find a missing side. We use the Pythagorean theorem to find the missing side when we knew 2 other sides. We're going to use SOHCAHTOA to find a missing side when we know an angle and a side. So when you start one of these questions, pretty much every single time I want you to write out SOHCAHTOA. This is going to help you figure out which of these trigonometric ratios you're going to use to answer this question. So I look at my angle, 57 degrees, and I say, okay, from here, what sides on my triangle am I dealing with? Well, this 15 centimeters is the longest side, is across from the 90 degrees, so this must be my hypotenuse. And this one is straight out from the angle, doesn't actually make part of the angle, so this must be my opposite side. So I look at my options and I say, okay, I've got, in this case, opposite side and hypotenuse, that's O and H. So looks like it actually works with opposite and hypotenuse. Cosine requires adjacent, which I don't have, and tangent also requires adjacent, which I don't have. So I'm going to set up my sine ratio. So I'm going to write sine, and instead of writing theta in there, I'm going to actually write the degree, sine of 57. So that's going to tell me what the trigonometric ratio should be for 57 degrees in a triangle. And that's equal to the opposite side, which in this case is x, divided by the hypotenuse, in this case 15. And in order to solve this, I need to get the x by itself. So because it's being divided by 15, I'm going to do the opposite, and I'm going to multiply by 15. And what I do to one side, I'm going to do to the other. So 15 times sine of 57 degrees. Going to nicely cancel my 15s, and that's going to give me x. So pull out my calculator again, and I can just type that in straight up. 15 times the sine of 57 degrees. And it tells me then x is equal to, round again to 2 or 3 sig figs, 12.58 is going to round to 12.6. Look at the units of my question, that's 12.6 centimeters. Okay? So, write out SOHCAHTOA to choose which of these ratios matches the information that you've got in the question. Write up your ratio and solve for whatever's missing. Let's try another. I've got 11.1 centimeters from my angle 28. Again, this is going to be straight out, is going to be the opposite side. And this would be my hypotenuse, which I do not have. So this must be the adjacent side, which is right next to my angle. So in this case, again, I'm going to write out SOHCAHTOA. And I'm going to go through and eliminate. So I don't have the hypotenuse, so I can't use so because it's got the h in it. Don't have the hypotenuse, I can't use ka because it's got the h in it. I do have opposite, I'm looking for the adjacent, so that is what I am aiming for in this question. So I'm going to write out tangent of my angle, 28 degrees, is equal to opposite, in this case, 11.1, and adjacent in this case is x. So in this case, again, I want to get x by itself, but x is in the denominator of my fraction. So in order to just get it out of the denominator, I can't just divide by 11.1. That's still going to leave it in the denominator, and it's still going to leave me with problems. So I'm going to multiply by x on both sides. because what that's going to get me is the x out of the denominator. So the next line is going to look like this. X times the tangent 28 degrees equals 11.1. And now that I've got that, in order to get x by itself, I can divide by the tangent 28, because it's x times tangent 28. I'm going to divide both sides by tan 28. And that will leave me with then, okay, this crosses out, and I've got x equals 11.1 over tan 28. Type that into my calculator. Let me pull out my calculator again. 11.1 divided by tan 28, and that tells me my missing side is 20.87, round to 2 or 3 sig figs, so 21 or 20.9. Again, look back at your question, units in centimeters. Let's put boxes around our answers to keep track of them. So the two kinds of ratio questions that you're going to end up setting up are either with x on the top, pretty straightforward, just multiply both averages on the bottom, or x on the bottom, and when that happens, you'll notice that our x and our tan 28 actually just end up switching places for what we're going to type into our calculator. So the 11.1 stays on top, and the x and the tan 28, they swap positions, and we type that into our calculator. So if you can handle that kind of algebraic manipulation, you should be good to go with this lesson. So again, we use SOHCAHTOA to find a missing side when we know one of the angles and we know one of the sides and we're looking for another side.